Hello, today I'll be talking about generics in Java. First I'll start by talking about generic methods, and then in a separate video I'll talk about generic classes. So let me show you this problem first, and then we'll go from there. So imagine that we have an array of type integer, array 1, and let's fill this array with random numbers. And here we want to create a method, let's say named print, to print this array. So public print, and this method will accept an array of type integer, returning nothing. And here in this array, in this method, I'll print the elements of the array. We'll start from the index 0 and then array.length I plus plus here, and now we want to print the array, then some spaces. Let's make it print here. Let's say that we want to print line, new line. So I is less than the array.length, and this is the method. So here, if we want to call it, then print, then passing the array, and let's run it. Here is the array. It's just what we entered here. We are able to do so. Now, let's say that we have another array, and this array 2 of type double, and here we'll enter some values to this array the same way as we did and here again. Now we want to print this array, so we want to send this array to a method called print and then to print it. So let's try to print this array using the same method that we just created. So now I am sending this array, and here, look at this, we have an error because we said that this method is accepting an array of type integer, but now we are sending an array of type double. Okay, so here this is an invalid statement because we are sending an array of different data type that is not matching this method parameters. So to solve this problem, we need to copy and do the same method, but now instead of receiving array of integer, now I am receiving an array of double. So we have two methods. Now we fix the problem, run it again, and we can see both of them. Now, what if we have another array, third array of type character, or even fourth one of type string? Then we have to keep adding these methods. We have to overload these methods to accept these different data types. So, but what's the point here? Here, look at this. All the methods are doing the same job. And exactly, if you look at here, it's doing the same code. It's the same code there, the same the same method, the same function, and everything is the same, except that we are using or accepting different parameters. So instead of keeping adding these methods over loading these methods, then we have to think about something more professional, easier for you guys, and will make it shorter. The code will be shorter. So instead of keeping repeating those, I'll do this. I'll delete this one, and I'll just keep one copy of this method, and I'll convert this method into a generic method. So instead of declaring a specific data type, I'm using a variable t here to represent the data type that will be substituted later on at the compilation time by um, fixed data type like integer, double, character, string, whatever we want. So look at this. Everything is good now. We have just one method, as you can see here, just one method that can be good for that is good for every data type here. So even if we have another um, array, let's try this one, array 3, and let's say we have VB and just uh, random data here, and let's say that this is the third array. And now I want to print this array. I will send this array to the same method, and now it's good. Look at this, it's working now. Run it, and here is it. This is the output of the method, and this is what we want to achieve. So this is the generic method. This method can be uh, working properly. It will be working properly for every data type, but because we did change this method to a generic one, and we substitute the data type by a variable for the data type. Okay, let's take more examples here. Let's say that we want to sort the array. So sorting the array, the elements of the array or the array itself must be comparable. Must be comparable. That means we have to select the data type that is comparable and work on that. So to do this, I'll start by declaring a new method. Let's start with this generic method, and here um, sort t array, and this is a method that will sort the array. Here we specify a very generic data type. So here the compiler is expecting any data type, but as we mentioned, this must be a comparable um, data type, or the elements of the array can be compared to each other in order to sort them. So we will do some modifications to this code, to the signature and the header of the method, but let's do the process of sorting the array. So here I'll start from I equals 0 and I less than the array dot length minus 1, and then I plus plus. I repeat this one to walk through the elements and compare each element to the rest of the array. And here j equals from I plus 1, then j is less than, or yes, less than j, it's less than the array dot length, and here j plus plus. Now swapping, before that, let's say if the elements of array I is greater than the array of j. If so, then we can do the swapping. So here t temp, and this is the temporary variable temp equals to a of I, a of, sorry, ar of I, ar of j equals to ar, here, sorry, it's ar I equal ar j, and then ar of j will be equal to the temp. So this is the swapping process. Now, look at this. Here we have some problems. So to fix this, we need to set the limits for this data type, the boundaries for the data type. So T will be restricted to this thing. It's extending the comparable interface. So if this data type is comparable, then this method will be good for it. So comparable. So we are setting the upper bound of this data type. So anything is extending the comparable, In other words, T is a subclass of the comparable interface or comparable or any other comparable object classes. Sorry. So now, because this data type is comparable, and we know if a class is a comparable, then we have a method called compare to, right? Compare to, and now we are comparing this to our array, and if it is greater than 0, then we'll do the swapping. So this is what we call restricted or bounded data type, and this data type must be comparable in order to use this method. Because why is this? Why we are restricting the data type? Because not every data type has compare to method. So that's why we are saying that this data type should be or must be extending the comparable and the integer. As you can see here, double strings, all of them are comparable uh, classes. So here, let's say that we want to print the array, then sort the array, and then print it again. Printing, sorting, and then printing again. So look at this. This is the unsorted array, and this is the sorted one. Now we can do the same thing here for the double. Let me copy this to speed up, and here I am changing this to array 2, then sorting the array. So this is the first array, unsorted, this is sorted, unsorted, sorted. And then the last thing here, we can do the same for the third array, and you can see here it's working. So look at this. So we can do better than this output. We can just print some messages to display which one is the original and which one is the sorted array. So here in this example, I demonstrate the concept of generics, and here I worked on the generic methods. So here is the first generic method that is of data type T. It's unbounded data type, but here with the sorting method, it's uh, sorted. It's sorting the array, but here we have this condition, and this is the thing. Thank you, and we'll share another video regarding the generic classes as well. Have a great day.